Come back to the class. So we have 4 exponent x plus 6 exponent x equals 9 exponent x, okay? Now let's divide each time by 9 exponent x. So you're going to have 4 exponent x plus 6 exponent x equals 9 exponent x. So here by 9 exponent x, here by 9 exponent x, here by 9 exponent x. All right. Now let's apply the quotient to a power rule, okay? So a exponent b over c exponent b is the same as a over c exponent b. So our equation becomes 4 over 9 exponent x, okay, plus 6 over 9 exponent x equals, okay, 9 exponent x over, 9 over 9 exponent x. Alright, so our equation becomes 2 exponent 2 over 3 exponent 2, all in a bracket exponent x, plus, and we can write 6 as 3 times 2, and then 9 as 3 times 3. Now 9 over 9 is the same as 1, and 1 exponent x is 1, okay? So 1 exponent x is 1. Alright, so you're going to apply the quotient to a power rule here again, okay? So you're going to say 2 over 3, okay, exponent 2, and then here we have the exponent x plus, now this 3 will cancel this 3, so we have 2 over 3 exponent x equals 1. All right, so you're going to have, okay, you're going to apply the power of a power rule here, okay? So we say a exponent m times c should give us a exponent c times m. So we have 2 over 3 exponent x, okay, squared, okay, plus 2 over 3 exponent x equals 1. All right, so now we have 2 over 3 here, and we have it here. So let's say, let a represent 2 over 3 exponent x. So you have a squared plus a equals 1. Now let's transpose 1. So you have a squared plus a minus 1 equals 0. So you can see what we have is a quadratic equation. So we are going to use the quadratic formula to solve it. Now let's compare our equation to a squared, okay, a squared plus bx plus c equals 0 to find the values for a, b, and c. So you can see a equals 1, b equals 1, and c equals minus 1. All right, now let's put this into a quadratic equation. So the quadratic equation, okay, you can say, so now we are quoting the quadratic equation. So you can say a equals minus b plus or minus b squared minus 4ac all over 2a. All right, so let's do the substitution. So we say a equals minus 1 plus or minus the square root of, now b squared is 1 squared, a is 1, c is minus 1, all over 2 times 1. So we are going to have a equals minus 1 plus or minus the square root of 1 plus 4 all over 2. So this gives us a equals minus 1 plus or minus the square root of 5 all over 2. All right, so you can see you have two values of a here. So let's call the first value a1. So a1 equals minus 1 plus root 5 over 2. Now let's call the second value for a2. So a2 equals minus 1 minus square root of 5 all over 2. All right. Now, but A stands for 2 over 3 exponent x. Now, by inspection, you can see A, or the value for A, cannot be negative. Okay, therefore, we cannot equate 2 over 3 exponent x to A2 since A2 is negative. So this is rejected. Okay, so A2 is rejected. Okay, so you can say 2 over 3 exponent x is not equal to A2. Okay, so let's focus on A1. So you can say from A1, okay, we can say 2 over 3 exponent x equals minus 1 plus the square root of 5 exponent 2. Okay, minus 1 plus the square root of 5 over 2. All right, so this is what we have now. Now let's apply logarithms. Okay, so we are going to apply logarithm here. So we say log 2 over 3 exponent x equals log, okay, minus 1 plus the square root of 5 all over 2. All right, so let's apply the logarithm definition. So we know that log a exponent n base b is the same as n log a base b. So our equation becomes x log 2 over 3 equals log minus 1 plus the square root of 5 all over 2. All right, so we're going to divide here by log 2 over 3, here by log 2 over 3. So you cancel this, this also cancels this. Okay, so we have x equals log, okay, minus 1 plus the square root of 5, okay, over 2 over log 2 over 3. So this is our answer. So you can simplify further, or you can punch this on the calculator and then get exact value for x.